This video is designed to give you a sense of how to collect variables or collect ends or collect like terms when other variables are involved besides just numerical coefficients. So if we look at these two expressions here, on the left-hand side is something that we're very accustomed to seeing and can clearly be collected as negative 2n. Now, the question is, how does that happen? What we're actually doing is reverse distributive. What we're saying is that we have 3 ends and 5 ends, and we're subtracting 5 of those ends from 3 of those ends. So what we actually have is 3 minus 5 ends. Now this is distributive property in the reverse direction. In other words, instead of distributing, we're collecting. So if we look on the right-hand side, of course, by the way, then 3 minus 5 is negative 2, and therefore what we have is negative 2 ends when we simplify the 3 minus 5. So if we look on the right-hand side, and we wish to understand exactly how this works, we can look at this and say we have a ends, and we have b ends that we're subtracting from them. So what we have is a minus b ends. So the simplification or the collecting of ends in this is often called factoring out, but it is collecting like terms or collecting the ends, and we say that we have a of them minus b of them, so we have a minus b of them. This allows us to simplify formulas or solve equations that have variable coefficients as opposed to exclusively numerical coefficients. Here's one more example of collecting ends where we're starting with a fairly complicated, messed up expression, and we'd like to collect our ends as best as possible. Now that might involve doing some distributing and cleaning up of the expression before we can find our like terms. So if we did that, we would get xn minus 6n plus 2, because we have to pay attention to our signs. And then we could collect our ends. Now that we've freed the ends up from the parentheses, we can collect our ends and say we have x minus 6 ends plus 2. Now, of course, the 2 is not a coefficient of an n term. It's just a constant term. So it would not be involved in the collecting of the ends. So there you go with collecting ends from a more complicated expression. In this next slide, we have a slight variation on one we just did before, and that is that we have a of them and we have n of, and we have 1 of them. So if you think of the 1 as a placeholder for the coefficient, what you clearly then have is a minus 1 ends. And of course, the point is that if you distribute this back out, now recognize that you could also write it this way because of commutative property. It's irrelevant whether it's a lump times n or n times a lump. If you distributed this back out, you would of course get what you started with, which is na minus n. And of course, that could be rewritten as an minus n using commutative property. And you get what you started. So to collect an minus n, you think of n as 1n, and you need that placeholder 1. This turns out to be very obvious once you've thought about it for a little bit, but initially sometimes when variables are involved as coefficients, losing sight of that 1 is a challenge. Keeping track of that 1 is a challenge. Many people lose sight of it. So here would be a final example of collecting like terms. What we have is 3na's minus a half of an na, and therefore we can reverse distribute or collect our a's, and we could have collected n's as well, and we'll look at that in just a moment. But we can also now simplify this, and 3n minus a half n is 2.5 n's, or 2.5 n's. times A. So what we have is 2.5 NA, or 2.5 AN. So we could have simplified and collected N's, or we could have simply collected NA's. So we could have said we have 3 Na lumps minus a half Na lumps, and that's going to give us 2.5 NA's, or 2.5 AN when it's written alphabetically, which is more conventional. Hope this has helped.